Okay. So we have the. I'm gonna just start where I left off yesterday. I have that on the breadboard. So it started out as a bass fuzz, but now it's something else because I added a lot of stuff. So, but basically it's still a bass fuzz, or at least the bass is. So I've opened up KiCad 7.0 already, and in here you are well, you have a window like this, and you have this stuff here, and of course we want to start a new project. Let's give it a name. Let's name it the Boss Box. There we go. So now it should be on its own folder. I'll just get it up there. And it gives us the two essentials, which is, and the thing we'll start with is the schematic. And we click that open, and I'll track this here, and we get greeted by this window, and so that is where we'll be drawing it. And first thing I'm gonna do is I'm gonna go on the top left here, and I haven't done this for I've been having like a summer vacation, so schematic setup, net classes. And I will tell, I can say that I'm not a pro on this program, so and it might take a while before I remember how to do things here, like I said. Here we go, page settings, A4. So this might take a while. And the other thing is that it's gonna include switches, and I haven't done those yet, so, and I might need to do these things called footprints for them, but so yeah, let's put the issue date there. It's not a revision. Title, the Boss Box. There we go. Company, Rutina. Comment. Modded base fuzz thingy. There we go. And now when we click OK, we should see all this stuff here updated. Alright, and it was A4, so we should have lots of room. And I'm gonna show you what so this is the thing we had. So I'm gonna start lay it down according to this. And yep, I'll just, you don't need to see it, it's boring. So what would I like to do first? Add a power symbol. Add a symbol. So here are the things we'll be using pretty much from here. probably. I haven't even used these, so I don't know what those are. At a junction. And a no connection. But yeah, you can pretty much do anything you want with this program, I think. But yeah, we could add the transistor like first, and in here we get this sort of view. As we can see, there are quite a lot of items you can add, so you can actually do your own libraries, and I have because it just it saves time, a lot of time. So because you end up, when you do schematics and layouts in here, you use the same stuff pretty much all the time. So but I can't find the, hey, there we go. We're actually, this is what we're looking for. Instead of the 5088, I tried that one, but I went with this one. So then we have it there. We have the how it looks like, and there we go. Click it and then just add it there. Alright, and that's our starting point. Now so this will be our, yeah, let's start with adding the 100k resistor also. So there we go. The most used resistor, small symbol. So for some reason, I don't know why I have two, so we'll get that one. There we go. So that's the 100, and now we should take that select item instead, and we can put the value on there. So 100k, there we go. And you can change the places of these, click all to move them all around. And I'll be running to here every now and then. There we go, 100 is there. And from there we take, so here's a power symbol, recently used power, +9 is what we're looking for. Let's do that. The R is the hotkey for rotating. And in here, add wire. Just boop. Now they should be connected. Alright. Oh man. Now I'm gonna 2 pole down there. 2 pole. Oh, mechanical. Ah, goddamn, this might take a while. 2 switch connector, audio, blah, blah, blah. So it's a huge list to go through. I'm gonna take a lot of breaks. Where could it be? Switch. Oh, dip. Switch double pole. Unit A, unit B. 1, 2, 3, 5, 4, 6. Yeah, so that's what we want. Yep. All right. Here we go. And I'm gonna rotate these. And I'm gonna rotate this as well. No, actually, I'm gonna. Oh yeah, and then I'll put. Let's get it there. This one also. So what I'm doing now, I'm adding. This little switch here. I'm trying to add. Yeah, I'm trying to add that little switch there, with which has 1, 2, 3. So, and it's replacing. Not this one, actually this one. Am I correct? No, I have to check. Yeah, so that's what it's replacing, this one in here, so we can have some 2 options. So let's bring them back here. All right, and when we look at the so the left side is, it goes from up to up, from up like 1, 2, 3, and then it jumps back to the other side up, and 4, 5, 6. So that's the number of the pins on the switch. So pins 2 and 5 are connected to the breadboard, and then 1, 4, 3, and 6 are the ones that have the different diodes. So I'm gonna try to find a way to somehow get this working. Let's rotate it after all. Then so we're gonna take that to 2, and then let's go from to 5. Oh, no. All right. then let's take this. Potentiometer. That's the volume, so I'm gonna there we go. And it's I think 100. Let me see. It is 300. So that would there we go. One is actually going ground, so I'm gonna get a symbol. There we go, ground. And then I'm just gonna hook that up. Hopefully. And you make sure to check that you don't have gaps. Sometimes if you have a like a, well, not saying both move, but I've done a board and I've had a like a gap between the part and the green line. That was really, I hadn't like drawn it all the way through, so that was really annoying. So now we're in here, and this section, and so we're gonna have a option for 2 different capacitors here. So again, recently used, most used. So unpolarized capacitor, small single, and it looks like that. Let's put that is oh well, I need to actually, so let's give that 3.3 NF, and this is gonna be like 47 NF, I think. I'll check, but let's work with those. Now I need to connect this to 1 and 4. I'm gonna take those aside. There we go. Oh, so 1 and 4. And these are going to 3 and 6, this one. So how do I do this? I haven't like jumped over. So if I pull this one, and then I take this one and put it. Oh, I think I said 4, 1 and 4. Then I have this one, and that should go from 3, 6. Yeah, so it doesn't jump over. So how do I do that? God damn it. Is it actually connected? Because there's no junction in there. Well, I'm gonna leave it like that for now. And I'll check later. Alright, and then you can just Control C, Control V, so the copy paste works in here too. And this is gonna be a tone. Yeah, I'm boring, I'm just gonna name it like that. So I added a tone control, which was, let me check. It's A100K. And I'm gonna put that K with big letter as well. And our volume output 2 goes to, let's see. Well, that actually goes, let me check. It actually goes to an output, so let me check. I need to add that. I've been using this, so I'm just gonna name it as just output. There we go. Can I leave this open? Yep, there we go. And this one goes here. There we go. And then from 3 we go to the here. Let me check. I'll turn that around for whatever reason. Let's try to do it like this. So we go like that, and then two goes in here, and this one goes to ground, so let's just copy that one. This might not be pretty. I'm not even sure if it will work at this stage, but let me check. Do we actually need this? Does that look more appropriate? Now, are we hooping? Are we like select connection? No. I'm just like trying to figure out if that's connected, but it doesn't have a junction, so if anyone that out there knows, let me know. Yes, like I said, I'm not a professional, so. But alright, that part should be done. And these I'm just gonna copy and paste. So here, let's move these. As well. So yeah, and then I'm gonna move these around already. Sorry. Where is the picture? There we go. Looks about right, I think. Alright, let's take the diodes. Do I have them as the most used ones? I do. We could actually search for, there we go. So this one is the actual one we have there. So, and then let's search for an LED. There we go. That's the other diode we have for the clipping. And the same thing works here. I'm just gonna put these around like this, and we're gonna move these around for a bit, and then again 1, 4, and then 3 and 6. There we go. Alright, and then I'm just gonna drag this one over here where I'm doing some unnecessarily big moves, but it's nice to have space. There we go. There we go. And then this one I'll take and put here. There we go. Then we have check actually, and for some reason I have a polarized cap in here. I think it was this way around. Check. It is, yes. So we'll take that and drag it there, and then let's copy the output, and it's gonna be the input. Odd input. Input. There we go. And that portion should be done. Oh yeah, there we go. Like I said, oh goddamn. Guess that would have been an error, a big error, when you go manufacture a board and then you have that, you're gonna be bummed. I think we can, oh, now we can, I can put these in here. You know. There we go. And then put these in here. I can name them a bit differently. They're going there right now. Don't want to get them in line. Line up. There we go. Oh no, it's not actually. Let me do it. There we go. All right, and so that one was, I think. I don't know why. Don't ask me. But it's 100. It works. No, I'm gonna change that. All right, and then from here we are going to one more potentiometer, but this is gonna be fuzz, and it's B2K. Okay, and up. I think I have this pin assigned EPC C E. All right, a little break. Alright. So alright. Yeah. So that one is going in here. Let's make it pretty, bit prettier. Actually, let's take this one, rotate it, and let's take it. Come on. What? I mean, this one. And now, here we go. Take it there. This one. Yeah, now we have the space. So, from one, we are going there. Okay, and from the fuzz spot 2, we are going to pot 1. Let's put it more this, and from 1, actually, let's just copy this one point. There we go, and there we go. Oh, this is weird. Oh, why? No. Come on. Okay, then take these. And just there we go. Bit more. Just this one. Alright. And let's move the whole. I mean these down a bit. And then I think we can move all this down a bit. No, not actually like that. Just like this. No, it's oh, actually, yeah, works. There we go. And let's take all of this and move it a bit like that. Alright. And yeah, I'm pretty happy about that now. And then I'll add for these, I'll do this. And there we go. I'm pretty sure there's better ways to do it, but this is how I've done this. It's because I want to have pads in the board. Plus 9. There we go. All right. All right. Now, could we actually make this? Let's see again. Page settings. A5. How does it work? Yeah, it just moved everything in there. But can we actually move the whole page? No, just move everything. Okay. I can squeeze. No, let me check. Let's bring those here. Doesn't need to be that big. So there we go. And then I'll just bring these up a bit. I can actually do it with these also. Alright, and for fun, I'm gonna just... yeah, nothing yet. So we can do the check. What? Not driven by anything. Them cannot. Yeah, it gives this because, yeah. So, and then we have footprint assignment tool. Let's annotate that. And this is the next step. So we're gonna apply the footprints to all these components. So when we get to the actually laying out the board, we need to choose from here, from this list, and this might take a while, but let me just check. So LED, I'm using a 5mm. So view selected footprint, so that's it. But of course, well, we actually do, yeah, we need to, so let's put that there. What did I do? I need to choose it. So LED THD means it's the SMD is for like really small parts. So click that, and now the D2 should be in LED. And for these, do I have my most used? I do. So I have let's check the footprint. So it's like that. How about this? It's like that. So let's take that for ground, and then that for input, output, R100. So I have this on my list of most used, and the beautiful thing is you can make your own footprint libraries, like I said in the beginning. So that's one thing you want to do if you start using this program, because it will save you a ton of time if you because you don't have to go through all this every time you're doing this work. And I'm not sure if there would be something that would, there we go, perform automatic footprint assignment. We can try that. Apparently didn't work, so we're back to adding them like this, but and now we need to find a resistor, small. This one's it. Then we have I think I've made these myself because I couldn't find a. So now when we select and look at the footprint, what? Oh, I'm still working on that. All right, so so this is a footprint I made. So it resembles an actual component you can get from Data Electronics. And there's one that's, but as you can see, it's the height of that is smaller, and that doesn't reflect the actual part. So I had to modify that footprint, and there's an editor for that, and you could actually see the 3D image if you would have one. You can also, if you're really savvy, you can, if that's a word, you can actually make them yourself also. And I'm choosing these because I will have, when I make the board, I will have board mounted potentiometers probably, and I want them to be on the back side of the board. So that's what I'm gonna do. And then we can choose these, so radial. And you can always, if you're unsure, you can, every component has a data sheet somewhere on the internet, and you can also see the dimensions of the component in there. And of course you can always measure, because like we see here, these are the measurements. So, and of course when you design pedal PCB, you probably want to make it, well, not as small as possible, but because sometimes that would mean it would be really awful to deal with when you're soldering, and but you want it to still be compact, and probably that's so it's good to use. And I think we can use this for that, and then get these for, and we selected footprint and then have the 3D model. No footprint loaded. What? Oh, we already went there. So we selected footprint, and then we have the 3D model. So that's like a really tall capacitor, a box type, which is kind of like wrong because I use let's check that one because I use greenies a lot, so I use the green ones. So what? Why? What's happening there? I'm not sure. Huh? 3D model was weird. So yeah, we're gonna take that one. Okay, then the switch. So this might take a while. Button switch. And this is the point where I might know that find out that I have to do it myself. Button switch, because if I click this, yeah, nothing like what I want, and I can't see the 3D model, so none of these will do, I'm pretty sure. SMD, it's definitely not. Button switch, keyboard. Yep, not it. Alright. And a small break again. God damn it, the mic was off. Yeah, so I was explaining about how you can make your own footprints here, and I was saying that I can't find a footprint for a switch like that. So for the switches I have for changing the capacitor on the circuit, or the diode or the LED, and I don't seem to have one here, so I have to make one myself. So the next thing is I went to the footprint editor and create a new empty footprint. So I'll have to check the data sheet for this footprint, and then I'll probably just measure it myself with a caliper, and I'll draw a working footprint for the switches I have on the board, or in the schematic. And right now I'll do this. I'll actually oh yeah, here I am. But yeah, I'm gonna ask a few friends about the schematic. Does it like look right? So I'll be gone for a bit. All right. Back to it, and this is the footprint I'm going to be using. Mounting. 13. Alright, so let's start this. Let's take mils in here. It's good to, the grid size. There we go. So 1, 2, 3, 4. Let's start by drawing a line for let's see. I'm just gonna, or we could rule area, draw a rectangle. Let's see, 11 by 11 by, and then I'll just measure with my caliber. 11 by 13. Actually 11.5 by 13, I think. So, but let's do it like that. There we go. Let's put, there we go. That's the reference. Here we go. And then we'll start doing the pads, and we're just gonna do one, and the shape is going to be oval, like that, and then we'll start carefully. I'm actually gonna bring the grid size down to 2.5 now, so we can get these in line. And then we have the sheet, so let's look at that. So here we can see how, like, oh, it's actually, it says 12. Well, I'm gonna get it up to 12. 2.4, is that correct? Let's measure. Yeah, it seems to be, it's like 2, so we'll leave some relief there. So the whole size should be, there we go. Let's take that oval, so I'll put it up to 2.5. 2.4. That means offset. Gonna bring that down to 1. Let's do the pad size for like 3. And then how flat are they? They are like a mil, so we'll bring that to 1.2, and then that will be like 2, no, 1.7, and 3.5, no, that's 2.5. So what do we think now? How does that look? Now I'm getting the ruler, and I'm just gonna check that we have from the longest point here to the longest point here, we have enough. So we have 2.4. That's more than enough, actually. So I'm gonna bring it. No, actually, let's do it like this, and then I'll measure this one. So from here, I'll measure that. How much was it? It was like 1. Yeah, it's 1. So let's do it again. So here we have 1. So from that point, how much do we have for there? So that's 2. So yeah, we should be clear. I'll do this. I'll put that to 2.6, bring that down to 1.1, and I'm gonna increase the pad size so we have some area to solder to, and there we go. That looks good. And then we'll just copy paste, and we should get that. All right, and then we'll see if they can fit nicely alongside each other. And let's get the sheet out again. So it's 4.8 from like the center. And first I'm gonna just increase this and for that I'll change the grid size for a bit, and then do it like that, and we have that 12 like it said. No, we'll have 11 now and 13. How much is it? It is actually 12. So I'm gonna get it even. One more. There we go. Let's put that there. And then we'll change it to 0.5. Alright. So we'll do these first. So I'm gonna There you go. And one more. Okay. Let's check this 4.7. 4.7. Alright, let's measure. And I'm gonna bring grid size down again. 4.7. So that's not enough. Should be there. So I'm gonna actually check how much is it from the it's 1 mil from the, so I'll do this 1 mil. There we go. There we go. And then I probably just need to, no, it was actually, that was a mil from there. So alright, there we go, it's pretty close. I'm gonna just make this a bit larger, I think. Then let's, so that's 5 already, and that is 5 also, and we wanted 4.7. 4.7. Yeah, let's aim for that. So there we go. Bring up a bit, and then 4.8. Let's put it, there we go. Now we have that 4.7. There we go. And then let's bring this up. 4.7. It's not. There we go. There we go. And then I'll put it back here, and I'll just drag them all at the same time, like this. And then I'll copy paste the whole thing. There we go. I'm gonna remove the text there. And this is, so this is path number 2. That is path number 3. That is path number 4. And that is path number 5. And guess what next? What's next? It's path number 7. No, okay. It's path number 6. Alright. And then let's check. So 4.8 from the centers. We should be able to measure that. So that's like 6 now, it seems. No, I'm gonna, get it to the center. That's too much. So let's bring them both a bit closer. We're at mils again, so let's bring them a bit closer. All of these. Let's measure from the side. So that's like when you press Control, you can just freely measure 1.350 ESC, and we get out of that mode. 1.4. They're not totally centered, but the most important part is this. So it's 5.2 at the moment, and we should be 4 and something. So I'll have to bring these ones a bit closer still. And probably this just a bit tiny. There we go. Now let's check. 4.6. So let's put it there again. Just move one. Oh, one and one. There we go. Now when we measure 4.8, that should do it. All right, and then we save, and we can save it on in there already. And now when we clear that and we check our most used ones, there we go. And of course this would work for a momentary switch of the same size also, but you know, now it's this. And like I said, the pins are going 1, 2, 3, 4, 5, 6. And when I add that one, so now we can exit this one. It's saved there. Bing. We don't have the, of course, the 3D model, but we'll have to do without it. And now we can go here, check our most used ones, and there we go. And there we go. Apply schematic and continue. Okay. So and then we have this here. So annotate is usually a good thing. We could then, of course, here's the electrical rules check. It's a really good tool, and we have these usual mistakes because I'm not quite sure why, but you know, it's probably good because of my messed up habits of the way of doing these. And there we go. Another break. All right, and anyone doing working at their desk, it's really good to just take lots of small breaks, and then of course longer ones. But you can get your, neck, lower back, shoulders, like in a bad jam if you don't take care of that. I've asked other people to review my schematic and see if there's anything wrong with it, because, and oh, it should be good. Oh, what's happening there? Okay. Why is there a junction? I'm gonna, there we go. I'm gonna just for safety measure do that again. Probably will still give a warning about these, yeah. So ground value, footprint, blah blah blah. Alright. Save tools. Noted. And then when we feel that we have our schematic is correct, I'm gonna name these. I'm gonna name this the diode switch. There we go. And this will be the cap switch. Alright. There we go. It all seems to be in order. Tools noted again. There we go. And then everything is in here. Oh, this one doesn't have a. We'll use the. We'll use that one. There we go. And then open PCB in board editor. This is the next step after we have all these things checked. So this should be good. I hope. I'm not sure about these, but that's one thing I ask. Like if someone can. People also know how to use this, so I think you can actually simulate, but I haven't learned it yet. But you could simulate what this thing does, and it actually, lets you run a simulation of your. But like I said, I don't know how to use it, but you could simulate your this schematic, I think, and it would give you information about is it working, essentially. So that would be nice. But next thing we would do when we have working schematic and all the stuff laid out, and would be this. Here we go. So we have this window, and this is the other window. So now when I click this off, we can still see the schematic here, and then update PCB with changes made in the schematic. We click that one, and it will drop our components in there. All right. So that's what we have now, and we'll start making a board for all these components, and and I'll see what I'll come up with. I might try something new. I might even go through the schematic and make changes. I'm not sure yet, but first I'm really to see like there we go. Oh, what did I move? I'm just gonna look at it fast. Oh yeah, it seems to be working. And this one's 2 and 5 are going. It's gonna check really fast. Oh, let me check. So this one's here, this is here, and then this one. Switch to in there. I think it looks. Yeah, I think it looks correct. It seems to be correct. But if I did that, I can just delete them all and start it again from scratch. If you made mistakes and so here we are. Right, I'm gonna save this one. There we go. So I'll eat, and I'll leave this one like this for now. Actually, we can just for fun these edge cuts. Can we do it like no? Draw a rectangle, edge cuts. There we go. Now we have this view, so we could go here and we can actually see. But of course, like I said, I don't have the 3D models for these, so I can't really see those parts. But the other parts are here and can be seen, so that's nice. And I probably need to add a few of these. But yeah, that's where we'll continue. Alright, and I'll end the stream for now, and I'll be probably back for later, especially if I get confirmation that the schematic is correct. So yeah, alright, I'm off for now. More later.